Okay, right, so number 9 here, I am going to give myself a blank page to work on. Okay, so now I'm going to follow the hint exactly as it's given. The components of the cross product equaling 0, that's going to be interpreted as statements about proportions between coordinates of these vectors v and w. Okay, so that's a lot. That's a mouthful. Let's write down. It starts off with, okay, we'll observe that the cross product is equal to 0. Okay, so that's v2w3 minus v3w2 v3w1 minus v1w3 and then v1w2 minus v2w1. Okay, equals 0, 0, 0. Okay, now that just says cross product equals 0. That's what we're given. Okay, if the cross product is 0. Okay, now the hint says, by way of that, I can interpret as a statement about the proportions between corresponding coordinates of v and w. Okay, so now how can I interpret each one of these equations here as a statement about the proportions of coordinates of v and coordinates of w? Wow. Let's take these one at a time. This statement I could interpret as v2w3 equals v3w2, or I could interpret that furthermore as saying that v2 over v3 equals w2 over w3. All right, now why this is useful? Unclear, right? But I've done what the hint said, which is to interpret the givens as statements about proportions. Okay. All right. So then, analogously with the others, well, I did the first one, but let me do the same thing for the other two statements. So that one tells me that v1 over v3 is equal to w1 over w3. And this one says that v1 over v2 is equal to w1 over w2. Is that cool? Okay. All right. Okay. All right. So there's. Okay. Let's go back to the hint. All right. Assign names. Assign names to those proportions, and then rewrite each of the given vectors as a multiple of the same vector. Okay, let's not get ahead of ourselves. Let's assign names to those proportions. Let's do that first. So we have 3 proportions over here. Whoops, hit the wrong button. Scroll. That, and that. So let's give them names. And arbitrarily, I'm going to call this one A, and this one B, and this one C. Right, just doing what I'm told. Okay, next part of the hint. Rewrite each of the given vectors as a multiple of the same vector. All right. Oh, how am I going to do that? So, what can I say about V? Let me just get that out of my way. What can I say about V? V is V1, V2, V3. And let me remind myself, the hint says to rewrite as a multiple of some vector using these proportions. Right? So again, just doing what I'm told. How can I incorporate A or B or C into any of this? Right? So what I'm going to do, and there's multiple different, well, there's 3 different ways I could go about this. I'm going to take advantage of the fact that there's W3s and V3s in these denominators, and I'm going to use that to rewrite V1 as a V3. Okay, and then similarly, whoops, let's use a different color here. V2 is CV3. And of course V3 is just V3. Now keep in mind the hint was to rewrite as a multiple of another vector, and so this does, I mean, what I've done is I've written all three of these coordinates as some multiple of V3. Yeah.
Oh, wait, never mind.
Okay. So I can factor out the V3. I get V3 times A, C, 1. Now I'm going to do the same thing for the W's. W is W1, W2, W3. Let's see, what can I say about W's? Well, let's see, let me reclaim the color purple here. W1 is AW3. And W2 is CW3. So same trick, right? Oh, and of course W3 is still just W3. So same trick, and I see that what we've got here is just a different multiple, W3 instead of V3, different multiple of the exact same vector, A, C, 1. Is that cool? I forgot who was interested. It was you guys, I guess. Okay. Is everybody good so far? Yeah. So we're basically done at this point. V, and let's see here. Oh gosh. Well, yeah. So you see here, V and W are multiples of the same vector. Therefore, at least one's got to be a multiple of the other. Which I guess is what we were supposed to show. Oh, let's see details. Non-zero. Yeah, because they're non-zero, then they've got to be parallel. Yeah, that's right. Yeah.
I did very similarly.
Mm-hmm. Before I get into that, is everybody comfortable with this argument here? Does anybody have any questions about? No. Okay, let me stop this recording.
Actually, I have a question.
Oh yeah. Okay. Yeah.
Why is it 1 on the? Why is it AC and 1?
Oh, yeah, because you could think of this as being 1 times V3.
Yeah.
But you don't even really have to do that. But I chose to factor out the V3 just because it's a common factor here. Mm-hmm. And if you factor out V3, there's an A left over, and then there's a C left over, and then what's left? If you factor V3 out of V3, the 1 is what's left over.
Why is it V3 in the first place? Is my question.
Oh well, because that's what it had been. Right. I mean, I chose to rewrite V1 and V2 using the proportions that I found.
So why isn't there no B then?
Why? What now?
Why is there no B? Are you supposed to?
Yeah, because I didn't need it, as it turned out. So I wanted to rewrite these things in terms of something that I had convenient access to. So it was convenient for me to rewrite V1, V2 in terms of V3.
But aren't you going to set the proportion V1 over V2 equal to B? V1 over V2 equals W1 over W2 equal to B?
I could, but I didn't need to, is my point. Right? I mean, I achieved my goal of realizing the vector V as being a multiple of this constant vector. And so you just don't need to take advantage of that other. It's like we had more capability than we really needed to make use of. Yeah. Okay. Cool.